Okay, welcome back everyone. Glad to see you all here. And of course, I hope everyone online is tuned in and ready to continue. We're continuing here in Theta Stage with some programming stuff now. And our next speaker is Matheus Albuquerque. He is interested in the areas his areas of interest include JS and compiled to JS languages, DX, and performance optimization. Aside from public speaking about these, Matheus works with tech labs and is teaching front-end development. So without further ado, let's hear web performance APIs you probably didn't know existed. The stage is yours.
Thank you. I hope you can all hear me okay. Cool. So yeah, it's great to be here and build stuff. I'm loving the event so far. Hope you all are too. Yeah, we're here to discuss some web performance APIs for. Hope it's gonna be different stuff for you. Yeah, this is me. I am Matheus Albuquerque. I am a front-end engineer at Medallia. I also volunteer with Tech Labs, and you can find me everywhere as Y Combinator. And by the way, most of the links for this session, including the slides and etc., are gonna be over this QR code, so feel free to scan it. And whenever you feel like, okay, this needs more discussions, this is like really deep content and etc., look for this emoji. This means we can discuss more in the after party and stuff like that. So I'd like to start by reflecting a bit on the whys I am here and we're here. So to that, I'd like to propose an exercise of going from this to let's discuss the stuff we know already, with stuff we're probably doing. So what do we know? We know about HTTP2, and we know it's got like full request multiplexing. We know the performance optimizations of that. We know the server push API part of that. It's crazy. We know we should compress our JavaScript code. So we know, for example, we have gzip, and we have alternatives like Broadly by Google or ZStandard by Facebook. And we know it's got a lot of improvements and etc. There's research out there about image CDNs, how they can optimize our images, bring savings from 40 to 80% of stuff, not to mention the work they save us, for example, when transforming and optimizing images and everything. We can optimize our libraries or third parties. So we can, for example, defer the loading of some of them. We can replace huge libraries like Lodash or Moment.js. Moment.js, for example, you can use data.fns instead and that kind of thing. And we can also optimize them by updating. So, for example, a lot of those libraries like React, Angular, Vue, etc., when going from one version to another, they usually try to squeeze in some improvements. So React, when jumping from 15 to 16, for example, they reduced a lot of the bundle size of React None. And we can always offload stuff to web workers to optimize performance and optimize the main thread. We also know about bundle splitting. So if we have a bundle that takes a lot to process, a lot to download, and that kind of thing, we can split that into multiple chunks and do that only when it's necessary. And by doing that, we can only do dynamic imports. So we can import parts of our bundle only when it makes sense to import them. And this way, we're also optimizing. I don't know about you, but even though we are aware of all these things, I constantly have this in my mind of facing the realities of our industry. And this is, for example, a map showing some performance metrics from the app I've been working on the last couple months. And here we can see, for example, we have like good or interesting metrics for most of Europe, the US, and some part of the South America. But the moment we move to some parts of Asia, for example, we have not so really good numbers. And then we get to countries where actually we have pretty poor performance. And whenever I see this kind of thing, I feel like it's kind of a joke about web performance is easy. It's just like drawing a horse. You have like 4 basic steps, and then you just add some tiny details. And yes, this was supposed to be the joke of the talk. So that's kind of the reason I'm here, to share some stuff I've learned through this journey. And it all starts with measuring. So I'd like to propose a reflection for you. What does it mean for you to be fast? Or doing one better? If you had to summarize web performance in one single metric, what would you go with? For example, would you say it's load time, responsiveness, smoothness? I'd really love to have your help on that. So if you could scan this QR code and share your opinions, it's gonna be on the screen for the next couple seconds. And yeah, one metric, by the way, I'm gonna be giving away swag, stickers, whatever. It's gonna motivate you sharing your opinion. And yes, one metric, whatever you feel like it's the most interesting one. And yeah, it's always tricky when you do something like 40 seconds because it sounds like a lot of time and you have to keep striking conversation throughout the whole time. But yeah, 10 seconds to go. I see there's some people still scanning. So yeah, I guess we're good to go and move. And I'd like to start by, because for example, I mentioned load time, for example, but in this one piece of code, and it's like a real app, it's a shopping cart, everything is loaded. I mean, there's no bundle being downloaded, no images, it's no assets, no nothing. But still, user is clicking and they cannot get what they want because the main thread is blocked. And by the way, this is called rage clicking. That's a really common behavior in users. We've all done that probably. And not only it's something that happens a lot out there, but we even have metrics to measure that, like first input delay and many others actually. And the thing is, a lot of the loading metrics we have, they don't actually capture the whole user experience journey. So that's why I propose that exercise, because we need to start thinking in metrics that capture the whole thing in terms of what really matters for the users. So it's really common for us front-end engineers. By the way, how many of you here are front-end engineers, please? Cool. Half of the crowd, I guess. Yeah, a bit less. So yeah, it's really common for front-end engineers to brag a lot out there, like, hey, my app loads in this amount of seconds or even milliseconds, and we have performance jokes and etc. But it turns out that load metrics don't happen to be a single number. So before we move forward, I'm curious to see what were your answers, so hopefully it's gonna load. Okay, so yeah, load time, responsiveness, perception, okay, smoothness, fast. That's good. Oh yeah, so I can say that load time and responsiveness are the most ones. So, for example, I'd like to share with you some other metrics. So first, for example, perceived load speed. So that's probably what we most talk about, and that's, okay, how quickly can our app load everything and render visual elements to the screen, etc. Then we have the most voted one by you guys, load time. So okay, how fast can our page load and run all the required JavaScript that it needs in order to do the things. But then we have things like runtime responsiveness. That is what was basically missing in the two examples we saw. So for example, okay, the page is fully loaded, but how quickly can it respond to the user interaction? Because you can simply have your main thread in the browser blocked by some long test that you happen to be running. And not only that, there are a few other metrics like smoothness that we don't usually think a lot. So sometimes we use a lot of transitions and animations and etc. But they, for example, they cause bad FPS in the app, or they just don't flow. And we could be here all day. For example, we have metrics like layout shifts. So for example, how much of your web page shift with elements moving around the page in a way that it actually causes unexpected things in the user. So that's another metric, for example. And the thing is, we get to this point where the truly way to know how how our web page performs is actually measuring as our users are interacting with it. So we have a lot of good tools in the lab. So probably heard of Lighthouse or many others. But real user measurement is really important. And we can get one example from history. So there's this guy called John Antonolit, and in my opinion, he was the first guy who conducted the first experiment with real users back in 1746, because he gathered 200 monks in a circle and wired them with idle, and then he discharged the battery through the human chain. And by doing that, he was measuring the latency of electric chains, of electric signal, and he happened to discover osmosis back then, hundreds of years ago. The good news is the browsers and the whole web has evolved in a way that we don't need to discharge batteries in our users to measure things nowadays. So there are a lot of APIs we can actually use to understand what's happening and optimize things. So this leads us to going from stuff we already know, or I didn't know, to stuff I didn't know and I thought it was worth sharing with you. And starting with measuring with the web platform. So I've split in 4 different groups the APIs we're going to be discussing. The first one is some general stuff. Then we're gonna have APIs focused about timing, and APIs focused on profiling the app, and then some sensors APIs for detecting what's happening in the user's device. So the first one is probably one of the most simple, is the page visibility. So you can use it either by checking document.hidden and visibility state. So you're gonna have the current state if the tab is idle or not. Or you can register an event listener and check for these kind of changes. And it's really helpful because there's a lot of things you can do based on that information. For example, if you have some time-based defense or some net requests going on, heavy stuff being downloaded, you can cancel that. Also, you can do that in a way to start fetching media or even some code chunks. Let's say you did code splitting as we discussed in the very beginning, and some less important parts of the chunk are still yet to be downloaded. So you can start downloading them when the tab is idle, so that once the user is back, they're gonna have the full experience already downloaded. And you can pause ongoing stuff, so video, carousels, or any kind of media that's happening, you can avoid it from happening in the background. The second one, and it's probably the most important one, is the performance observer, because it's going to be the basis for a lot of the other APIs we're going to discuss. So basically, it allows you to subscribe to a lot of different performance related events, and most of them are callbacks that are basically happening when the browser's idle. And you get to choose what you want to listen for by pressing observer. You instantiate a new performance observer, and you add your logic inside that, and then after you have the observer, you do observer.observe, and then you choose one type of entry. So let's get to see some types of entries. The first one, and it's related to one of the things we discussed in the beginning, layout shifts, is the layout instability API. So either you're a front-end developer or not, you've probably seen like when elements suddenly shift because they were loading, you had no idea they were loading, and then they just pop up in the screen. So this API gives you a list of layout shifts happening on the page and information about that. For example, the duration, when that happened, what triggered that. Again, you use that with the performance observer. I know some of you cannot see it because, but basically, and you can filter also the kind of entries, because for example, of course, if the user had some input, there is going to be a layout shift, so you can filter only the ones that matter for you. And the most interesting cases is when you combine that with tools that use that metric. So for example, this is web page test. They have a feature called film strip view, and you can use that to measure layout shifts. This is one example from my personal web page where I had my avatar being downloaded from a different source. So basically, there's this blank space here. Actually, there was text, and then there's this blank space, and then suddenly my picture pops in there. So this tool spots this problem using this API. And then once you know you have this issue, you can address that using, for example, loading states. So you've probably seen that in Facebook, Instagram, or any other apps out there. And you have a lot of libraries. I know some of them in React, but I've seen in Angular, Vue, or most of those popular frameworks nowadays. So once you spot that with the layout instability API, you can fix that with this. For the timing APIs, because we had a lot of them, I split them in 2 groups. And in the first group, we're going to discuss user, element, and event timings. The first one is user timing, and it's all about gathering information and then calculating deltas. So you use it's part of the performance object in the browser, and you can do performance.mock, and then you mock the beginning and the in the end of some thing you're interested in figuring out. And then you can do performance.measure, and then you pass the beginning event and the finish event, and then the name of your task. And then you listen with the observer event with the type measure. The first one thing I love about this API is that it integrates really well with a lot of tools. The first one being Chrome Developer Tools. So any event you register with that API, you're gonna see here under User Timing tab. And then you can, for example, just quickly check for the events you're particularly interested in. Not only that, but it plays really well with performance audition tools out there like SpeedCurve. So you can register, let's say I have a hero banner or something that takes long to render. You can register with a name, then you say the mark you added in your code, and you can track over time how it's going. So if you did some sprint or focused on optimizing performance, then you can see after you push that to production if it actually optimized that one thing for your users. The other one is element timing, which is also really useful. So as the name suggests, it's about checking the render time of some elements, and it's especially useful for things like large images or large critical chunks of text, like above the fold things and etc. And that's actually the basis for one metric we've probably seen in Lighthouse or other tools as largest contentful paint. This one is one HTML attribute of distance from you. So you just add element timing, and then you pass which element you want to register. So you can add to images, to blocks of text, and etc. And then you start observing them. And again, it integrates really well with tools out there, so you can see, for example, the evolution over time. And there's a bunch of scenarios where you can use that, and it exposes a lot. It exposes a lot of timestamps in the events and etc. And it's also the basis for the first input delay metric. That was the exact problem in our first examples. It's also really useful because you can derive a lot of information from the timestamps it's gonna give you. So for example, you can access the finish time and the start time, and you can have deltas. So you can build your own metrics with that. And there's a lot of situations. Those are situations where I have used it before. So for example, when you have a table with a lot of data, and then you have those short arrows that you click to reorder or to filter some information, etc. And because it's a lot of data, it takes a lot of time. So you can measure the latency of that event. Or for example, when you have a slider, you have a table view with a lot of, not a table view, but let's say you have some charge or like a lot of data plotted. So you drag a slider to filter that information there. So you can, for example, measure how long it's gonna take this one specific event. And this last example, it's a simple one, but it's actually useful depending on how much. So let's say you have a menu and you hover over that menu, and then it's gonna add an event and show you something when you hover. So that's another example you can measure. This section is my favorite one, profiling, exactly because of the amount of information it gives you about the code you're writing. So we have the long tasks API, user agent specific memory, and the self-profiling API. The first one is long tasks API. If you haven't seen long tasks before, those are basically what you see when you're inspecting your app because something is really slow and you see those marked with red. That's probably because it's taking more than 50 milliseconds. And by the way, this metric is based on a performance model called Rail. So whenever you see those and the red flags over there, those are long tasks. And this API is gonna basically help you see when the main thread of the browser is blocked because of you. And that's why it's the basis for the time to interactive metrics and the total blocking time metric. And examples of what happens when you have long tasks blocking the main thread is this. So for example, here I have a button, I have some different kinds of inputs, including a text field in a box, a checkbox, and I have a link. And here I'm virtually blocking the main thread, and that's what happens. So the page just gets unresponsive, and that's why it's bad. And you saw in the beginning some real world examples. Again, you use that once you instantiate a performance observer, you can do observe, and then this, you can filter for this type of event. And this is the kind of data you're gonna get. So you're gonna get the duration of that one long task, and you're gonna get, for example, what triggered that, if it was an iframe or a worker or the code running on the main thread, whatever. The other one, and that's a little bit less popular than the long tasks, but I would say it's also really helpful, is the self-profiling API. So you've probably seen the profiler we have in Chrome Developer Tools. So the self-profiling API is going to create that in the user's browsers, and you have two parameters you can pass. So they're part of an object. The sample interval is basically what frequency it's going to take those samples to build a stack trace, and the max buffer size is how big you want your stack trace to be. So basically, create a profiler, then you do anything that you know it is CPU bound. So if you have an operation, maybe it's some really you're playing with a lot of data, or it's a game or anything like that. You do the work, and then you collect the trace from your profiler, and then you can send to any analytics tool, maybe to your servers, to your blogs, that kind of thing. And so, yeah, it's really useful because you can profile a complex operation, but you can also use it to profile some libraries you're adding to your code. So you're aware of what's happening with your code, but you're not aware of what third-party code is adding to your app. So you can profile that, and you can combine that with other cool metrics, like the long tasks or even the event timing ones. And this one, it's more recent, and it's kind of supposed to, it's a long name, user agent specific memory. It is intended to kind of replace the one we used to have for measuring the total heap of the language. And it's really useful for memory leaks. So we are used to checking for CPU bound operations and that kind of thing, but we are not used to check for the memory leaks we are adding to our app. And it works by basically, it waits for the garbage collection to happen, and then it immediately gets information, and if it doesn't happen in 20 seconds, it's gonna force garbage collection. And the reason why I love that one is because memory leaks on the web, on the browser, they're really tricky because they can happen in a lot of scenarios. The most popular one, of course, is when we forget to deregister some event listener, but they can happen in our iframes as well, or even in our workers. So we are offloading things from the main thread to optimize, but we might have some memory leak inside our workers. And when we accumulate a lot of things in arrays, so the called sparse arrays, there's an amazing session by the team behind Chrome on how they were addressing memory leaks at the level of the browser, but also of the challenges doing that. But I have one example here. So we have an object, and we have two properties with two arrays. We have A with an array of 1,000 elements and B with 2,000 elements. And then we have set interval. And then we are constantly log object.a. So is there any problem happening here? Huh? Yeah, but besides that, for example, is B gonna be garbage collected? Yeah, exactly. Because garbage collection mostly in the web, it happens by checking not if it's used, but whether it's accessible or not. So usually, especially when you're beginning with the language, you would expect if you're accessing A and you're never using B, at some point in time it would be garbage collected, but it would not. And this is how you can use that. It's part of the performance object. You can do performance that measure user agent specific memory. And when you combine all of these three APIs, long tasks, self-profiling, and user agent specific memory, you get a serious amount of data about what's happening in your app, and that I personally think it's amazing. The second part of timing, and it's probably simpler, we have resource and navigation timing, which have to do a lot with downloading things and internet connection and establishing connections and that, etc. And we have server timing, which I consider to be one of the best front-end ways to back-end engineers help front-end engineers help them. We're gonna discuss that. So starting with resource time, again, you listen for resource events, and it gives you information. For example, one scenario I love about it is if you want to check whether something was fulfilled from cache or not. So if you have a service worker and you expect that to add something to your cache, you can, for example, check for entries, and one specific entry you expect to be coming from the cache, you can check the transfer size. If it was 0, it means it was fulfilled from cache. Then navigation timing, pretty similar. You listen for navigation, and you have a lot of information we're gonna see. One of them, for example, is the response start. But by doing that, you can check the time to first byte, which is another really common metric, especially if you're going from regular SPAs to SSR apps to optimize things. And the amount of information that navigation time gives you is amazing, because you have things about when the connection started, when it ended, lookup events in domains and etc., events from the server, when things started being fetched and etc. And using all that information, you can derive interesting things. For example, you can check the request time by doing request start and request start and response start. You can, for example, check the service worker startup time by doing response start minus worker start, and a lot of other things. And the last one is server timing. So basically, it's a way to actually measure things happening on the back end. So let's say you have any heavy thing happening. For example, your servers are doing a lot of routing or authentication / authorization business logic is heavy, I don't know. Or when you have to query for databases or other APIs, other services outside of your domain, anything like that, you can pass those request headers, and they have this syntax. So basically, you have a name, you have the duration of that event, and you have a basic description. And then in the browser, when inspecting things, the front ender is gonna see this. Let me zoom in. So there's a server timing tab, and you're gonna see all of the events that were registered by the backender when sending the API response. And you have a lot of libraries out there to add this to your application. This one is in Node.js, and it's a middleware meant to be used with Express. But you have middlewares for Java servers, PHP servers, probably other servers as well. Last part are the sensors. This one we only have 2: battery status and network information. So both of them are really simple. Battery status, as the name suggests, you can get information about the battery, mostly in phones that the users have. So whether it's charging or not, if it's about to be discharged, if it's changing with an event listener, and etc. It's promise-based, by the way. And my favorite one, that is network information. So again, you can check the current state with navigator.connection, or you can register for an event listener. And this is the information you get. So first, you get to know about the current status of the connection, whether it's 4G, 3G, 2G, etc. You have the round trip time as well. You have the time it's taken to download something, and you have this really useful thing that is whether the save data mode is enabled or not. So you know in your device when you click and when you enable that, because we're running out of mobile data and etc., you're gonna have this boolean indicating whether the user did that or not. And there's literally a dozen of scenarios that it brings to you. My favorite one is when you can switch the kind of content you're gonna serve based on that. So for example, let's say you have a video in your app, and the users, they got 3G or bad 2G connection. Then you can detect that and only render the thumbnail of the video instead of the full video. That's one optimization. Let's say you are preloading things, maybe when the browser is idle. So let's say, okay, the tab is idle, so I can start preloading things. But no, the users got 2G and they might be running out of data. So no, I won't preload. You can defer downloads and uploads, and you can even adapt to situations where they are offline. And a lot, especially media apps like streaming, like Spotify, Netflix, they use that. And this is one example in React, but you can have something analogous in any other framework. So here, basically, I'm switching based on the connection type. If it's 4G, I'm gonna render the video I have. But if it's 3G, I'm gonna render a thumbnail in high resolution. And if, for example, my default case I couldn't detect, or it's 2G, I don't know, I wanna play it safe and I render only the low resolution thumbnail. And maybe if the user clicks to download, then you can download the full video. And this idea is not new. People are writing about what's called connection-aware components from back 2018. So I know that they were doing a lot of this in React, but I think I've seen something similar in Angular as well. This is framework agnostic. And you have framework level abstractions. So for example, for React, you have libraries. For example, this one is React Adaptive, and it brings it's built on top of those APIs to detect information about the network or the battery status, that kind of thing. And this enables you to do things like Twitter. So Twitter on mobile, if you enable the data save mode and you're scrolling through the feed, it's not going to download, or I don't know if they changed that, but it used to be like this. It's not going to download the images. So you just see low resolution thumbnails, and then if you click, it's going to download them. So that's one of the use cases for that kind of thing. Whew, that was a lot. Okay, so we know some ways of measuring with the platform. Okay, I measured, I spotted some issues. How can I improve things? There's a bunch of ways, of course. Here are some of them. The first one are resource hints. They are also really popular, so probably you heard of some of them. And they all are based on the premise that if you can predict what a user is going to do, then you can go one step ahead and tell the browser how to optimize the experience for what users are going to do. So all those resource hints, they come in as HTML attributes. So you got PRECONNECT, you got preload, DNS prefetch, only prefetch, and pre-render. And so you add in, for example, where you are loading some fonts or some third-party scripts or some CSS, it depends. One example is PRECONNECT, for example. PRECONNECT. So it's going to allow the browser to set up early connections, and by doing this, you're optimizing the TLS, the TCP handshakes, and also the TLS negotiations if you have HTTPS. And by optimizing these two, you are reducing the round-trip latency. So let's say we have this timeline, and we have, okay, we loaded our HTML, we loaded our CSS, and in our CSS we have two custom fonts. So then they start loading. Because there are two, so I have font 1 and font 2 loaded, and then they're going to be rendered to the screen. If I pre-connect to, maybe they are Google fonts or whatever server fonts, if I pre-connect to that, we can move this like that, and then they're going to be rendered way before. And there's actually much more. For example, with DNS prefetch, the browser is gonna know, it's gonna know ahead of time what domains it needs to look up. This is really useful if you're doing resources from a bunch of different domains or even different CDNs, etc. You've got prefetch and pre-render. So they're similar. It just changes the amount of stuff they're gonna do in the background. So prefetch is gonna fetch the resources and store them, and it's idle time, by the way, and it's gonna store them in cache. And pre-render is going to go one step further and render them in the background. So when you go to that route or that part of the app, they are already rendered. And one thing I would say is that you're kind of making a bet here. So because with prefetch, you're spending users' network, which, okay, if you're on desktop, that's nothing. But if you are on 2G connection with not a lot of data, that kind of stuff, that's a big thing. Based on the fact that you think they're going to some route of your app or they're going to do some action. And pre-render is like the gamble is even greater because you're not only spending their network, but also their CPUs because it's going to render. And that's a bad thing if you have like low-end device. So it's all about collecting data and metrics and analytics. For example, it is really likely that this user is going, once they are in this route, they are going to this one next round. And actually, it was about 2018, people even started doing those decisions based on AI, analyzing user behavior and guessing which routes they would go after one route or another. So it's something you can use, but with certain responsibility. Another thing are priority hints. So basically, you can use them to increase or decrease the natural priority of something. So you can, for example, increase the priority of some important image that is maybe your largest one, or you can decrease the priority of some non-critical fetches. Again, one HTML attribute, so you can have high and low priorities. And one example is, let's say you have a carousel with a bunch of images. You can have the first ones being high, and then the ones that are not visible being low. That's one thing, and you can do that when loading scripts as well. And one thing that's less popular is you can also do that with fetch requests. So in the configuration object, that is the second parameter of fetch, you can set priority to low. And then let's say you have some request that's only important for the bottom of your app or the bottom of your page. So you can give priority to what's the user's gonna see first, and then defer that one. And again, one simple attribute. We also have responsive images. So for example, there's research out there that shows that the images that the users download on their mobile phones tend to be 2 to 4 times larger than they need to be, because they're meant for desktops. So we usually just write some CSS media queries and shorten images and that kind of thing, but we have source set. So by using the source set attribute, we can save a lot of bandwidth. So it works like that. It doesn't replace the source attribute. It's just another attribute where basically you have you can set things based on aspect ratios and that kind of thing. So it looks like this. And then if you fit one of those scenarios, only the smaller image is going to be downloaded. We have native lazy loading now. So in the past, we were used to have a lot of libraries for adding lazy loading to our apps and etc. Nowadays, we have that for images and iframes, which is great. So you can just pass loading lazy to both of them. And there's research showing that it's gonna save you a lot of first input delay, but also first contentful paint. So it's also great. And one of the last, and probably one of my favorites as well, is the native scheduler. So we are used in front end to have really poor scheduling primitives, things like set immediate, set timeout, and that kind of thing. Now we have this proposal that it's kind of an umbrella of proposal. It's called the Prioritized Task Scheduling API, and it's meant to be a more robust solution for scheduling in the browser that's integrated into the event loop. And the good thing about it is because it's aligned with the work of React and other teams from Polymer, from Google, the web standards community, and etc. And those are some of the APIs covered by this umbrella. So we're gonna have things for scheduling tasks. We're gonna have things for routing execution back to the main thread. We're gonna have things for waiting for certain conditions, and we even have APIs to check if the browser is busy processing some kind of input. And we have people using that out there. For example, Meta, they were the first one building the isInput pending API, and they're using that. There's a really interesting case by Airbnb on using the post task scheduler API, and there's this library called main thread scheduling. What they do is amazing, and their API was mostly inspired by this spec of the main thread scheduler of the spec I just showed you. Yeah. When I saw that all of those, or at least some of those, I was like really mind blowing for me. But there's even more out there. So there are CSS tricks we can do. For example, font display thread. You've probably seen that for optimizing how you render fonts. But you have things like will change to optimize your transitions in CSS. You have APIs like intersection observer that you can use, for example, to import some chunk of code only when the user interacts with some part of the app. You got off-screen canvas in a lot of browsers so that you can optimize canvas where you plot a lot of data. And there's stuff you can do in the back end as well. So for example, when you open a page and you usually go with HTTP and then it redirects you to the HTTPS version of that. So there's a little bit of latency going in there because there is a redirection happening from HTTP to HTTPS. You can use something called HSTS, that is HTTP Strict Transport Security, and by doing that you are reducing this one round trip. And you can also use Quick, which is part of the HTTP free spec, so you can also reduce round trips by doing that as well. Before wrapping up things, I'd like to mention some strategies for starting adopting some of those things. So as you probably wonder, not all of those APIs are supported in all of the browsers. So this is just one example of some of them, so you can see that browsers like Firefox and Safari, they lack support for some of the things we saw. Some of them run in all of the green browsers, but some of them not. So one strategy I have for that is I'd like to share. So here's a really simple example that's going to render a video of some previous talks and etc. And I want to use the network information API, which was one of the APIs we saw is not available out there in all the browsers. For this, I'm going to use this library. It's in alpha, so don't use that in production. But just get the abstraction for now. So it's a library meant to bring pattern matching to React code bases, but you can do analogous things in other frameworks. So what I have here is I have two components. I have a video component and a preview component, and I'm conditionally loading them. So they're going to be two chunks of code in the end. And here I'm using use network status from that library I showed for network information, and use pattern match from the pattern matching library I just showed. So the code looks like this. So I'm wrapping things with suspense from React. Those who are not familiar with React, suspense basically allows you to suspend the rendering of some part of your component tree until certain condition is met. And here I'm handling the different cases. So for example, I'm handling, okay, if the connection is 2G, I want to render this tree of components with the preview. If I cannot get the connection, then I'm gonna render the video because I want to have the full experience and etc. So this is the first example. I'm running in Safari where it's not supported. So I'm showing I could not detect, and I'm rendering the high resolution video. This is the second example in Chrome where the connection is supported, and it's 4G. I could tell it's 4G, so I'm rendering the full video. Here I'm using DevTools to simulate a network throttle so that I can get to the 3G connection. So I'm gonna see it's 3G connection. You can see it's just the image, the preview of the video. And the other interesting thing is this is the 3G scenario. So if you check the networking tab, the only chunk of code that was downloaded is the preview one. As you can see, preview.tsx. And in the scenario where it was supported and it was 4G, the only chunk downloaded was the video one. So I'm saving the users. I'm going one step further and even saving them from downloading that one extra chunk they would have to. So going back to the original reflection and thinking why I'm here and why we are here because a lot of us, either front-end developers or back-end developers creating APIs, we build things that are gonna run in browsers. And I don't know about you, but I realized recently that I don't think a lot about which browsers I'm using or my apps, for example. And I started checking that, and this was, for example, from an app that has about 8 million people opening that in a month. So this is the top 10 browsers. And of course, you see iOS mobile, you see a lot of Chrome and even Safari and etc. And we have Explorer in the bottom with a small percentage. But when you start exploring more that, I saw a lot of things like, for example, almost 2,000 people opening that from a BlackBerry, or people running on Samsung browsers or Nokia browsers, and even more, there was people opening that from a PlayStation. I would never thought of that. So there are a lot of browsers out there, and we should keep that in mind. Those browsers, they run on different devices with different connections and etc. And we are usually facing some reality checks. For example, that first input delay, if it's bad on a web browser, on a desktop and etc., on a mobile device it's going to be even worse. So there's research showing that for example, it tends to be 7 times worse. And those apps, they have different network bandwidths. So when seeing the network thing, for example, we thought, okay, but we are all running on 4G. But it turns out that a lot of the globe, they still have, as a majority, 3G or even 2G connections. So depending on your audience, that's really important to keep in mind. And not only that, even if you have 4G It doesn't mean to be fast. So just this is showing the current state of 4G, not the current, this is from a couple years ago, but the state of 4G across the globe, and it ranges from 6 megabytes per second to 44. So even if you're running on 4G, it can still be different. And all of this is going to be used by people in the end. And there was a research conducted by Google, and the top, this is in order of priority. So the top of the parameter of priorities for people is the time it takes to load a page, even more. And I was really surprised by that, because I would have thought it was how simple the site is to use, for example. But no, they care even more. And there's a lot of research in the past showing that. So in 2009, for example, they figured out that more than 1/3 of the British population, they became violent towards their computers. And there's a similar thing in the US as well. And then fast forward time, similar thing, they figured out that 500 milliseconds resulted in up to 26% of frustration and a lot of in 8% decrease of engagement. And this one is my favorite one, because they figured out, they literally attached heart rate devices to people, and they were checking their heart rates, and they figured out that the experience of a delayed website was as bad as watching a horror movie alone when it comes to the anxiety it caused in people. And yeah, I could go here all day with a lot of statistics, but the point is, people are going to abandon the sites. And this is going to reflect in business. So this is going to be really bad, because first input delay is just one of them. It delays TTI, and it's really bad for conversion. And when you put that on a chart and you compare to business metrics, this is one comparing the conversion rate decrease over the first page TTI. And this was conducted with really, really huge e-commerces. So to wrap things up, I would say that it's really, really important that we always try to correlate business metrics with performance, because that's what matters the most in the end. It's not like something you're going to tweet about. It's like conversion rate. That kind of thing is what matters the most. Depending on your users, don't take fast networks or fast CPUs, good devices, anything of that for granted, because it's not. And that's why it's important to test on real devices, real networks, that kind of thing. At the same time, it's important to avoid the observer effect and add a lot of complexity and etc. to our tests, to our measurements. And it's also important to get rid of the noise in the metrics. So isolate data coming from bots, that kind of stuff, fake behaviors. Depending on what metrics you're collecting, they're going to have a lot of clutter. The cliche of there's no silver bullet is true, so that's why it's important to identify the core metrics. These slides are available on this QR code. If you like that kind of session about web performance and etc., I do have other sessions, especially about the internals of React and that kind of thing. Probably the most important takeaway is, if you like stickers, I do have stickers. So feel free to approach me with your experience on performance, questions, and etc. And that's all I had for today. Thank you so much. Feel free to share feedback out there, here, ask questions, etc. Thank you. I think we still have time for some questions.
Sorry, I'm gonna, keep this on. We have time for about one question. So who's first and the only one?
Who's first?
Yay, me. Last? Okay, so I have a question. Do you ever get aggressive towards your computer?
Kinda, but I'm working on that, so way better nowadays. Otherwise, in the past I would be part of that numbers, but yeah, I'm doing better now.
Okay. Hopefully we'll get better and better at this, and none of us will be aggressive towards our computers anymore. Okay, that is all. Thank you again, Matheus, and we will be back in a few minutes for our next speaker.